Okay, here's the solution to the first heat and thermodynamics problem that I put in the survey in GetIt for you guys to do. It's not that hard a problem, so let's have a look at it. We've got the coefficient of linear expansion of steel is 11 by 10 to the minus 6 per Kelvin, and the coefficient of volume expansion of cooking oil is 0.62 times 10 to the minus 3 per Kelvin. A cooking pot is completely filled with 1.00 litres of cooking oil at 25 degrees C. If the pot and oil are both heated to a final temperature of 145, the amount of oil that will have spilled out of the pot is closest to. Now, I guess the key bit to understanding is that the steel and the cooking oil expand at different rates, and therefore it's obvious looking at the solutions the oil expands faster, and so it'll have to overflow because it'll have a bigger volume than the volume of the pot. So how much overflows? I guess we need to find the new volume of cooking oil and the new volume of the pot. So let's do that. Now, formulas. There's a formula that says the change in length is the coefficient of linear expansion times the change in temperature. And here is a more useful one. It says the change in volume is equal to the volume coefficient of expansion times the initial volume times the change in temperature, where the volume coefficient of expansion is 3 times the linear coefficient of expansion. Okay, so the change in volume of the oil is equal to the volume coefficient of expansion, 0.62 times 10 to the minus 3, times the initial volume, which is 1000 mils, because a litre is 1000 mils, okay, times the temperature change, which is 145 minus 25, so that's going to be 120. So the change in volume of the oil is going to be 0.62 exponent minus 3 times 1000 times 120, and we get 74.4 mils. Right, so now at this stage you might say, well, that's the amount that overflows, right? But there's a problem here, okay? There's a problem that the steel of the pot expands as well, so that's not the amount that overflows. We need to do another calculation. So what is the change in the volume of the steel pot? Okay, well, again, and I'll come back to this, it's equal to the volume coefficient of steel. Now they've given the linear, so we have to write 3 times 11 times 10 to the minus 6 times the initial volume, which we know is exactly 1000 mils, times the temperature difference, which is 120. And this is equal to 3 times 11 times 10 to the minus 6 times 1000 times 120 equals 3.96 mils. 3.96 mils. So the total overflow then is going to be 74.4 minus 3.96, 74.4 minus 3.96, which is 70.44 mils. Pardon me. And this is closest to answer D, so that's our choice. Now, one thing. There were two main errors people made. Just totally forgetting that the steel itself expanded, and the second one was not multiplying by 3 here for the steel because it's volume expansion. Okay, if you think about it like this, it's sort of obvious you have to multiply by 3. Take a cube. There's a cube made of steel, and we have length 1. Alright, now the linear coefficient of expansion tells us that if we heat it by a little bit, it'll be 1 plus delta will be the new linear dimensions of it, but then the volume is going to be 1 plus delta cubed, which is approximately equal to 1 plus 3 delta plus, I think it's 3 delta squared plus delta cubed. Alright, and you can see that these ones here, because delta's tiny, so these are infinitesimal, so we ignore them, but you can see now where the 3 comes from in our volume expansion. If you have a cube and you expand each edge by an amount that calculated from linear expansion, the total volume expansion is 3 times as much. You might say, but this is a cube, what about other shapes? Well, I'm not going to show it because I forget how, but you can show that it applies to all shapes. How did people go with this question? Okay, this is last year's results, and we can see that 1.6% chose A, that's a guess. 9.3% chose B, that's a guess too. 5.5% chose C, probably a guess. 47%, just under half, got it correct, and 36% chose E. Okay, so 36% made the mistake either of assuming the steel didn't expand at all, or of assuming that the steel expanded linearly and that they didn't use the proper volume one. Okay, done.